Okay, next example. What is the de Broglie wavelength of an electron that accelerate from rest to the potential difference of 1 to 5 volt? Yang 1 to 5 volt potential difference dia adalah V. Jadi kita guna formula asal dia lah. Lambda is equal to H over Z 2 MeV. Okay, nampak tak? So H 2 MeV. Okay, so then square root lah. So you dapat 1.1 times 10 to the power of negative 10 meter. Okay. Right, so next, the electron and proton have the same potential difference. Calculate the ratio of lambda electron over lambda proton in terms of ME and MP. Okay, first kali tulis dulu VE is equal to VP. And then kita use the formula relate with the potential difference and ada wavelength. So wavelength is equal to H over 2 ME potential difference. Okay, potential difference sama, jadi kita akan potong. Elementary charge pun sama. Okay, dua ni pun nombor constant, so H ni pun constant, jadilah 1 per. So what is the relationship between wavelength and mass? Because they said about proton and electron kan. Okay, jadi kat sini kita tahu relation wavelength adalah inversely proportional with Z(m) lah. Okay, lambda is directly proportional 1 over Z(m), tapi dia inversely proportional dengan Z(m). Yang tu kena faham lah. Okay, kalau kita tengok wavelength dengan M ni bukan duduk satu baris. Lambda dengan delta M ni bukan duduk satu baris. Jadi bila you nak cari lambda E over lambda P, M dia akan jadi terbalik. Okay, Z(mp) over Z(me), dia akan jadi terbalik sebab dia punya relation adalah per. Kita panggil inversely proportional lah sebab dia duduk kat bawah. Okay, alright. So inilah term dia. Okay. Okay, so next, electron is accelerated from rest through a potential difference of 1000 volt. Is the potential difference is double. Calculate the ratio of electron new speed to its original speed. Okay, dia nak ratio of electron of the new speed to its original speed. Jadi case awak ni mass adalah sama lah sebab dia guna electron. Okay, potential difference is double, maksudnya 2 times, jadi 2000 lah. Okay, so kita tengok dia nak ratio of electron of the new speed. Jadi kita kena cari apakah relation new speed dengan potential difference. Potential difference sebab mass sama, kita guna electron, and then 2E pun sama, E pun sama. So kita ada formula speed is equal to Z 2EV over M. Jadi kita ambil je yang mana ada relation. Okay, lepas tu potong 2E potong dan M potong sebab dia adalah benda yang sama. Jadi kita dapati what relationship between V and potential difference. V is directly to Z potential difference. Okay, jadi dia nak ratio of new speed to its original speed. V new over V naught, dia akan sama dengan Z V new over Z V naught. Ni adalah potential difference Kenapa duduk sama baris new dengan new? Sebab dia directly proportional. Kalau inversely proportional baru kita consider dia sebagai terbalik. Sekarang ni equation ni proof dia adalah directly proportional. So substitute the value lah. V new 2000, V lama 1000. So bahagi dapatlah 1.414. Okay, so you janganlah panik. And next dia kata the ratio of electron new wavelength to its original wavelength. Dia nak wavelength pula. Okay, so kaitkan wavelength dengan potential different. Okay, so wavelength dengan potential different kita akan guna formula ni. So yang lain semua constant, potong. So tinggallah wavelength, direction dia adalah relation dia adalah wavelength is directly proportional dengan 1 over Z potential different. So kita consider dia wavelength is inversely proportional to the Z V. Nampak inversely proportional sebab dia duduk kat bawah. Macam tadi ni satu baris, directly proportional. Kalau macam ni dia inversely lah, jadi dia akan terbalik. Nampak tak? Susunan dia tu terbalik. Okay, so kita akan susun lambda new over lambda naught is equal to Z V naught over V new. Okay, sebab dia inversely proportional relation dia. Kalau lambda tinggi, Z V ni akan rendah. Tu inversely proportional lah. Substitute the value, so we get 0.707. This is the ratio of the lambda new over lambda naught. Okay, next I explain the wave behavior of electron in an electron microscope. Relate the de Broglie wavelength of electron with the resolving power of microscope. 10.2c state the advantages of electron microscope compared to the optical microscope. Okay, this is electron microscope. Okay, you can see that dia besar. Okay, compared to the optical microscope. The practical device that relies on the wave properties of electron is electron microscope. It's similar to optical compound microscope in many aspects. So the advantage of the electron microscope over the optical microscope is the resolving power of the electron microscope is much higher than that of an optical microscope. Why? Because resolving power is depending on the wavelength. Okay, nak tengok resolving power, kita kena tengok wavelength of light tu ataupun wavelength of electron. Okay, this is because the electron can be accelerated to the very high kinetic energy, giving them a very short wavelength, typically 100 times shorter than those visible light. Okay, so based on equation de Broglie kata lambda is equal to H over mv. So kat sini kita boleh relate lah. Untuk dapatkan resolving power yang tinggi, kita nak tahu, kita nak tengok lagi detail kita punya specimen tu, wavelength you kena rendah, shortest wavelength. So untuk dapatkan shorter wavelength, velocity you kena tinggi. Okay, you kena tinggi. Jadi dekat sini dah terbukti lah di mana bila velocity ataupun kita beam with the strike with the velocity yang lebih tinggi from electron, so kita punya wavelength akan lebih rendah. Jadi bila rendah, resolving power akan semakin tinggi, and then you boleh tengok specimen typically 100 times shorter. Maksudnya typically 100 times lagi dekat lah compare the optical microscope. Okay, as the result, electron microscope are able to distinguish details about 100 times smaller. Okay, so there are two types of electron microscope, which are transmission, okay, and scanning. Transmission, they produce 2-dimensional image. Kalau scanning, 3-dimensional quality lah. So dia ada color pun boleh. Alright, so this is human hair. So you can see that the human hair specimen is come from electron microscope. Okay, then this is different light microscopy, transmission electron microscopy, and scanning electron microscopy. So where the image is view is 3D, this is 2D, and this is view directly from the light microscopy lah. Lagi tak detail lah, so you tengok dekat sini dia lagi dalam. Okay, so this is the difference between electron microscope and optical microscope. Electron microscope, the resolving power of the electron microscope is higher. The resolving power of the optical microscope is smaller compared to the electron microscope. Able to distinguish details about 100 times smaller, so less than electron microscope, of course, could produce 2D and 3D image, but optical microscope only form 2D image. Okay, this is the gambar lah. Okay, tak adalah pasal mana tapi di satu meja lah tinggi. Okay, that's all for this chapter. Okay, bye.